So the basic problem is to calculate the nth roots of 1. Now, in the real domain, of course, the answer is sometimes there's only one of these, one itself, and sometimes there are two, depending on whether n is an even number or an odd number. But in the complex domain, there are always n answers as complex numbers. 1 always has n nth roots. Now, where are they? Well, geometrically, it's easy to see where they are. Here's the unit circle. Here's the unit circle. One of the roots is right here at 1. Because 1's the end. Now, where are the others? Well, do you see that if I place, let's take n equal 5 because that's a nice dramatic number. If I place these at 5 equally spaced points around the unit circle, so in other words, this angle is alpha. Alpha should be the angle. What would be the expression for that? If there are 5 such equally spaced, it will be 1/5 of all the way around the circle. All the way around the circle is 2 pi, so it will be 1/5 of 2 pi in radians. Now, it's geometrically clear that those are the 5/5 roots. Because how do I multiply complex numbers? I multiply the moduli. Well, they all have moduli 1. So if I take this guy, let's call that complex number, I hate to give you, they're always given Greek notation. Well, all right, why not torture you? Zeta. At least you'll learn how to make a zeta in this period. Small zeta, so that's zeta. There's our 5th root of unity. It's the first one that occurs on the circle that isn't the trivial one, 1. Now, do you see that, how would I calculate zeta to the 5th? Well, if I write zeta in polar notation, what will it be? The modulus will be 1, and therefore it will be simply, the r will be 1 for it, because its length is 1, its modulus is 1. What's up here? I times that angle, and that angle is 2 pi over 5. So there's, just geometrically, I see where zeta is. And if I translate that geometry into the e to the I theta form for the formula, I see that it must be that number. Now, let's say somebody gives you that number and says, hey, is this a 5th root of 1? I forbid you to draw any pictures. What would you do? You say, well, I'll raise it to the 5th power. What's zeta to the 5th power? Well, it's e to the I 2 pi 5. And now if I think of raising that to the 5th power by the exponential law, that's the same thing as putting a 5 in front of the exponent. So this times 5. Now what's that? That's e to the I times 2 pi. And what's that? Well, it's the angle. If the angle is 2 pi, I've gone all the way around the circle and come back here again. I've got the number 1. So this is 1. Since the angle, the argument 2 pi is the same as an angle, is the same as the argument. Now, let's not write it that way. That's not. I have to. That's bad. No, it's wrong. It's just wrong. Since 2 pi and 0 are the same angle. So I can replace this by 0.